Romex cable, also known as non-metallic sheathed cable, can be used in metal framing similarly to wood framing. However, there are specific considerations and requirements you must adhere to, especially concerning grounding and protection from sharp metal edges. Let's discuss the use of Romex in metal framing and the importance of proper grounding techniques. In commercial electrical work, the National Electrical Code, or NEC, mandates the grounding of metal framing near main electrical panels. In residential settings, the NEC permits grounding of metal framing if it's locally required. In Maricopa County, Arizona, local regulations necessitate this grounding. Therefore, based on NEC 110.3b, you are permitted to ground all metal framing regardless of its distance from the electrical service. For effective grounding, it is recommended that this be done at each receptacle and switch box. You have several methods to achieve this. Firstly, you can use grounding clamps to connect the grounding conductor to the metal boxes. Secondly, if the boxes themselves are the grounding type, they can serve as the grounding point. However, it's crucial to note that using B-cap nails for grounding the boxes to the metal framing is not an acceptable practice. Instead, you must use screws or bolts equipped with washers to ensure a secure and reliable electrical connection. For additional grounding, consider running ground wires between the metal studs or joists, particularly at locations where there is a splice or 90-degree bend in the framing. This helps to create a continuous and robust grounding system throughout the metal structure. Now, let's discuss the use of Romex cable itself within metal framing. As mentioned earlier, you can use Romex in metal framing much like you would in wood framing. However, there's a critical difference. You must protect the Romex cable from sharp edges of the metal framing. NEC 334.40b mandates the use of a metal edge guard, also known as a bushing or grommet, for any cable that is less than 1/4 inch from a metal edge. This requirement is essential to prevent the cable's outer jacket from being damaged by the sharp metal, which could lead to electrical shorts or other hazards. The metal edge guard provides a smooth, protective barrier between the cable and the metal edge, ensuring the cable's integrity over time. To summarize, when working with Romex in metal framing, firstly, adhere to local grounding requirements, grounding metal framing at each receptacle and switch box using screws or bolts with washers, not B-cap nails. Secondly, use metal edge guards to protect Romex cable where it is less than 1/4 inch from a metal edge as required by NEC 334.40b. Ignoring these guidelines can lead to electrical code violations, potential safety hazards, and long-term issues with the electrical system. Remember, proper grounding is paramount for safety. A well-grounded system provides a low-impedance path for fault currents to flow back to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and to energize the circuit in the event of a fault. This minimizes the risk of electrical shock and fire. Additionally, proper grounding helps to reduce electrical noise and interference, improving the performance and reliability of electronic equipment connected to the electrical system. When selecting grounding clamps, ensure that they are properly listed and rated for the specific application. Choose clamps made of corrosion-resistant materials such as copper or stainless steel to ensure long-term reliability. The size of the grounding conductor should be determined based on the size of the ungrounded conductors in the circuit, as specified in NEC Table 250.122. When installing grounding conductors, make sure to properly tighten all connections to ensure a low impedance path. Avoid creating sharp bends or kinks in the grounding conductors, as this can increase impedance and reduce the effectiveness of the grounding system. Similarly, when selecting metal edge guards, choose guards that are specifically designed for use with Romex cable. The guard should be made of a durable, non-metallic material that will not damage the cable's outer jacket. The guard should also be properly sized to fit the cable and the metal framing. When installing metal edge guards, make sure to fully seat the guard onto the metal edge to provide maximum protection. The guard should be securely attached to the metal framing to prevent it from coming loose over time. Inspect all electrical connections and components regularly to ensure that they are in good condition. Look for signs of corrosion, damage, or loose connections. If any problems are found, they should be corrected immediately. If you are not comfortable working with electrical wiring or grounding systems, it is best to consult with a qualified electrician. They have the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. Remember to always follow all applicable electrical codes and safety regulations when working with electricity. Electricity can be dangerous, and it is important to take precautions to protect yourself and others from harm. By following these guidelines and best practices, you can safely and effectively use Romex and metal framing while ensuring compliance with electrical codes and regulations. This will help to create a safe and reliable electrical system for your home or business. Additional considerations to keep in mind include firstly, the type of metal framing being used. Different types of metal framing, such as steel studs or aluminum framing, may have different grounding requirements. Consult with a qualified electrician or refer to the manufacturer's specifications to determine the appropriate grounding methods for the specific type of metal framing being used. Secondly, the presence of other metal components in the building. If there are other metal components in the building, such as metal pipes or metal ductwork, they may need to be bonded to the grounding system to ensure that they are at the same electrical potential. This helps to prevent electrical shock hazards. Thirdly, the proximity of the electrical system to water. If the electrical system is located near water, such as in a bathroom or kitchen, additional precautions may be necessary to prevent electrical shock hazards. This may include the use of ground fault circuit interrupters, or GFCIs, or other safety devices. Fourthly, the age of the electrical system. Older electrical systems may not meet current code requirements. If you are working with an older electrical system, it is important to have it inspected by a qualified electrician to ensure that it is safe and up to code. Fifthly, the presence of any existing electrical problems. If there are any existing electrical problems, such as flickering lights or tripping circuit breakers, they should be corrected before any new electrical work is performed. Ignoring existing electrical problems can create safety hazards and complicate the installation of new electrical systems. Remember, electrical work can be dangerous, and it is important to take precautions to protect yourself and others from harm. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. They have the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. Grounding is a critical aspect of electrical safety, and it is important to understand the principles of grounding and how to properly ground electrical systems. A well-grounded electrical system provides a low-impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to quickly trip in to energize the circuit in the event of a fault. This minimizes the risk of electrical shock and fire. In addition to safety, proper grounding also helps to reduce electrical noise and interference, improving the performance and reliability of electronic equipment connected to the electrical system. Electrical noise and interference can cause electronic equipment to malfunction or produce inaccurate results. By providing a low-impedance path for these unwanted signals to float to ground, grounding can help to minimize their impact on electronic equipment. There are several different methods for grounding electrical systems. One common method is to connect the grounding conductor to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a direct connection to the earth, which helps to stabilize the electrical potential of the system and provide a low-impedance path for fault currents to flow. Another common method for grounding electrical systems is to bond all metal components of the system together. This helps to ensure that all metal components are at the same electrical potential, which minimizes the risk of electrical shock. Bonding is typically accomplished by connecting all metal components together using a grounding conductor. The grounding conductor should be sized appropriately for the size of the circuit and should be securely connected to all metal components. In addition to grounding and bonding, it is also important to provide overcurrent protection for electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip and de-energize the circuit in the event of an overcurrent condition such as a short circuit or an overload. Overcurrent protection devices are typically sized to protect the circuit conductors from overheating and causing a fire. When selecting overcurrent protection devices, it is important to choose devices that are properly rated for the circuit voltage, current, and interrupting capacity. The interrupting capacity of an overcurrent protection device is the maximum amount of current that the device can safely interrupt. It is important to choose devices with an interrupting capacity that is sufficient to handle the available fault current at the point of installation. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to be familiar with all applicable codes and regulations before starting any electrical work. Local codes and regulations may vary from the NEC in some cases, so it is important to consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable requirements. In summary, using Romex and metal framing requires attention to grounding and protection from sharp edges. Always follow NEC guidelines and local regulations. Use proper grounding techniques at each receptacle and switch box. Protect cables with metal edge gauze, and consult with a qualified electrician if needed to ensure a safe and compliant installation.